Start. Hi, I'm Joe Eulery. I'm the service manager here at the Grove Townhomes. I'm doing a quick kind of instructional video to cover going over heat pump aspects of ACs and working on them systems. So I have about 4 years with the company and in the trade. So these are some of the tools that you will need. Right here, these are 410 gauges. You need to look at a system because you can't mix a 410. These are R22 gauges. You cannot mix the refrigerants, so you need separate gauges for the type of refrigerants you're using. If you look, these are, like I said, R22, and these are 410. The other tools that you need: a multimeter and a 6-in-1 screwdriver. I have alligator clips here to go on for when you work on wires. Instead of trying to use the prongs, you can just clip it on, and then you can free up your hands and use something else. As you see, you have blue, yellow, and red. Your yellow hooks to your bottle. This hooks to your low pressure side. This hooks, and red hooks to your high pressure. Most of the time you charge off your suction off the low pressure to blue side. Okay, here I am inside a unit. This is our furnace or evaporator is it here. Okay, as you see, it's basic. You got your low pressure, your suction line, your high pressure, liquid line coming in from outside. Here's your service shut off. Most of the as you can see with this one is just straight. Some have fuses that go on with them as well. And then outside, this is our condensing coil. That's your 2 parts to the system. And for my property, out here in the shed, I have my breaker panel. This is one of the most important things that you can see. I have it labeled. If you can see, this is furnace, this is heat pump. This goes to the inside, this goes to the outside. They're on separate breakers. So when you get calls for ACs, you got common calls such as you're not blowing out air, or it's blowing out warm air, your thermostat has cut off, or it's just not turning on at all. There's other underlying issues. There's, you're going to get your odd end calls, but your most common for ACs is blowing warm air, your thermostat not coming on. Stop it. Okay, so the first thing you should do is, if you get a call, the first thing, if your thermostat is on, is to check your breaker panel and make sure your breaker hasn't tripped. A lot of times it's just the breaker had tripped, something shorted, or something had happened. You come out, flip the breaker, unit turns on, everything goes well. Also, if it's blowing out warm air, another thing you need to check is your inside unit right here. Your furnace is on, but look outside and make sure your outside unit, your condensing unit, is on too. A lot of times this will be running, outside won't be running. Okay. All right, so I took the liberty to go ahead and take a step. So first thing you should do before you get started, there's a little schematic right here. So if you look, it says right here R22. Sometimes it'll be green, sometimes it'll just say R22 on the system. Check before you do anything, because if you don't and you come in and it's a 410 and you put R22, you're going to mess up and you're going to have to change out the whole system. So that's the first thing before you hook gauges up. Make sure you check that you have the right gauges hooked on, because like I said earlier, you can't mix refrigerants. So what I've done is I hooked up the blue line. You don't rarely ever going to have to hook up the red, the high pressure side with AC. So you hook up the blue line to your gauges like that, and that yellow line right here be hooked up to your tank, whether it's 410 or R22. This is the inside of the unit. Very simple. Contactor, capacitor, defrost control board. Before you get started working and touching anything, there's 240 volts of electricity. Right outside, like right here, same thing inside, there's a service panel. You want to unhook this, that cuts to 240. If you do get shocked, you also want to make sure your thermostat is off, because you have 24 volts if your thermostat's on running. So if your thermostat's off, you cut all electricity to the unit. So if the outside unit isn't coming on, you want to push the contactor in right here. They got a little cover. Underneath there's a tab. You can push in a contactor. This is when everything's hooked up. You push it on. If it comes on, if you turn on and it turns on, and you'll hear the sound of the compressor, you want to check and make sure your gauges. Right now, because nothing's on, it's reading high. But a little, like right there, you want that needle splitting this 4. That 40 on the 4 on the 40, and if that means you have a good charge to it. So what you want to do, obviously all these wires, what you want to do, first thing is check the charge. If it has a low charge, you want to charge your unit to where it's correct on that end. Also, as I'm hooking this up, if you charge and it's at 0 there and there's no Freon in it, and more likely you have a leak somewhere, that you would have to go into a little more depth of trying to check and find out where the leak is along the system. I don't have everything for here. That's a little more in-depth, advanced, trying to find the leaks on your own. So you always want to keep an eye on that, because if it's at 0, that means you have a leak. If it's a little low on Freon, like 10, 15 psi, that's okay. But once you start getting 30, 40 empty, that means you have a leak somewhere in the system, and you need to find it, or you're just going to be wasting money on charging Freon over and over again. All right, last thing before I put the cover back on, simple ways. If you need to find what goes to what, you got a schematic. Some of you may not have it. Some of you are lucky enough that you'll still have this in your system. Okay, you got your compressor, you got your run cap, you got your contactors, stuff like that, and you can come out here and look to make sure everything's wired correctly. That's if someone came out and didn't know what they're doing, and everything's coded with the colors, and you just follow the lines. The thick dark lines are your high voltage, your small ones are your low voltage. High voltage issue, this unit will not come on. Low voltage issue, I'll show you here shortly. Inside in the furnace, there's going to be a 3-amp fuse on the blower control board. If that keeps popping, it means you have a low voltage issue, and it is not to do with the high voltage, and that'll cut out a lot of time trying to trace wires. All right, so I got my multimeter. So everyone should have one that has ohms and all that, everything, at least ohms, and to read alternating current, AC, and direct current, DC. So what we want to do, we change it to AC. I have some numbers, but this is an automatic. So what I'm going to do, I'm going to get my leads, okay? Black is common, red. So you find the white wire, you're going to hook that to there, you're going to hook this to here. So you hook them to, like so. I know it's cross, I don't think it really matters, but I always like doing the common just to be safe, to my neutral, and then my red to my hot. As you see right now, if you look, got 241 volts of electricity coming through at the moment. So when I unhook that service plug, that should go away. If I'm still reading, that means something's going on somewhere. Another thing you want to check too, if you check the sides, if the thermostat, these sides here, it should read 24 volts coming in. This is your common side, this will be your hot side. Alright, so I open up the panel. This is the inside of your furnace unit, your evaporator coil. You have your blower motor, which pulls the air and pushes everything through. So inside, come here. Inside, you're going to see you got your transformer, your blower control motor, your main source, and then a bunch of different relays. You got your high limit switch, and then you got a bunch of different relays, and that's mainly for heat, what a lot of this stuff does. So For all your relays, you want to test it with continuity. That I'll show you right here on my multimeter. If it clears up, I go to ohms, and let's see if I can get it clear. You should have that little symbol means continuity. So what you want to do is you want to put the leads together. As you put them together, beep, good. No beep, no good. That's another thing you want to show. So you want to check right there. It'll tell you if you have your 240 coming in. If you have your 240 coming in, okay, you want to be careful when you're testing for these power. Your transformer, it'll show you on top. Over there on this side, I don't want to test that other side where there's only the 2 wires, the 2 tabs. It's your 24. This side, where you see have 3 tabs, is your 240. So you want to make sure you got your 240 coming in here, and you want to make sure this transforms or drops or steps down into 24 volt. If that's all good, you want to unplug. If you see that little 3 amp fuse right there, if that keeps blowing, that means you have a low voltage issue. All right, so I'm back in the office now. So when you're in a unit and you get an AC call, there's the 2 main things you're going to check for. Your Freon charge. Obviously, the first thing is electric. You want to make sure you got power. If your thermostat's not on, outside unit's not turning on, furnace isn't turning on, if you don't have power, it's an electric issue. That should be the first thing you do. You need to trace everything from the source, from your breaker box, if you have your 240 and the 24 volt coming in, and then branches off from there. You got to trace what's going on with what line. It could be a blown fuse, it could be, there's 100 different things it could be. So that should be your first issue. If you got all your power and you're still getting like warm air and it's still not going, then you want to check and make sure you have a good charge. If you hook your gauges up and you get it says retard on your gauges, and you get that hook up, that means there's something wrong. Your compressor's not kicking on. You won't get a good charge, you can't get a good reading if you don't have your compressor on. Another thing you got to make sure is return vents aren't covered up, because airflow is huge. A lot of people cover it up. Make sure it ain't dirty filter, dirty coils, because if you have clean coils, clean filter, your system's going to run a lot better. So right now, this is a compressor I took out last week that was bad. Quick thing, with compressors and fan motors, they're all pretty much charged the same. So you want to go to ohms. I got an automatic, so you want to go, to your reading K. You want to ohms this out. All right. So you want to make sure you put your leads together. It reads 0 across. Okay. Stop the video. All right. If you can see, I got this. I ohms it out. My gauges are good. So you're in here. You're gonna have a common, a run, and a start. I don't know which order, but you want to, when you test these, if you could see, look at my multimeter. When I put 2 leads together, I don't get a reading on my multimeter. I don't get a reading on the multimeter right here. So what I want to do, you want to go common to run, common to start, and then you do start to run, and those 2 should, and then you add up the first 2, and it should equal that third one. That's the same thing how you test the fan motor. You do common to run, common to start. That's on the 3 wire. 4 wire is a little different, but most of the systems are 3 wire. And then the start to run should equal the first 2. If you're off a little bit, like 1 or 2 ohms, it's not bad. So like this, as you can see, nothing was coming up. It was an infinity reading. So what that meant, that means the compressor's burnt up. So you got bad compressor, you're going to have to change it out. All right, cut it. All right, another common issue that comes across is these boards. A lot of times these are misdiagnosed. The biggest thing, like you could test for these, is continuity. You want to make sure, like you say, you have a solid connection between them. So this one, I took out of a unit where the blower motor inside the furnace wouldn't turn off. So to test, to make sure this is good, if you look right here on the board, it'll say COM, that stands for common, NC, that means for closed, and NO means for open. So what you should have is, when you connect this common into the box here, put your common in here, okay, you want to be able to, you hear that beat, that's a good, but that's for your open. And closed, this is where this is bad, you hear a beat, that means it's fused to open. You want to hear no beat. The only time this should open is when the current runs through and it opens up the fan. So you're getting a beat from both of them, so that means it's fused open. So when it's not on, it's open, closed. So you don't want to beep in there. A lot of times too, if you look at the back, you can see where it's burnt right here, and then there's a bubble right here on the side too, because sometimes you'll have a tail sign. Actually, I did that wrong. Alright, you want it closed. The only time you want it open is when it's getting power. Reverse what I said about that. Yeah. Yep, sorry, that was my fault. But a lot of times you'll see there's like a bubble right here, and if you really look inside, you can see it's bubbled up, kind of melted, and then you can see where it's kind of burnt up on the back. So you don't want that. Alright, so that's pretty much all there is. There's not much to it. There's some extra like underlying issues and more advanced stuff. Once you start getting into brazing and getting into compressors and recoveries and the vacuum pumps and all that. But charging's pretty simple with R22. 410's different. That's a higher pressure. That runs at a higher pressure. So, but most of the time you can just find charts to tell you. And every system, what I showed at the beginning, with how it has the thing, it tells you how many ounces going in the system, what the pressures on the high and low side should be on the suction line and the liquid line. Everything's pretty much right there. So like I said, your first thing, always check electric, make sure all the breakers, everything, because sometimes you'll work, oh, it don't work, and it's just a tripped breaker. So always check electric first and then charge, and then from there you can trace it down. I'll show you kind of how you can test certain things. I messed up on the board obviously, but I corrected myself. But pretty much all you need is this screwdriver with the it comes apart. You know, you gotta have the 6-in-1 or 8-in-1, whatever it is, and a multimeter that tests ohms, continuity, and AC. And that's pretty much it. You can diagnose almost any system. Like I said, if you have that 3 amp fuse popping, it's low voltage. If it's no power, it's usually high voltage. And then just, you gotta be careful. Some stuff, like when you test for electric, you gotta be careful when you're testing not to electrocute you, because 240 is a lot of power and it will put you down. Other than that, make sure you turn everything off before you start servicing any system, evaporator, the furnace, or your condensing fan or coils, whatever it may be outside. And like I said, just always be aware of your charge. Make sure that if it's on 0, you got a leak. If you're like a couple down and it just needs a quick shot, you should be good to go. But I guess that's about it. Really working on ACs on the heat pumps. All right.